Okay, so today we are solving logarithmic equations, and we have done this a little bit by using one-to-one property. We've used that for solving exponential equations as well as logarithmic equations. So let's just take a look and remind ourselves a little bit about the one-to-one property. Okay, for exponentials as well as for logarithms, there is the one-to-one property that states if you have one exponent equal to another and they have the same base, then you are allowed to pull the exponents off and set them equal to each other and solve your equation. So we said as long as there's the same bases, there's one equal to another, then we can pull off the exponents, set them equal to one another, and we even said it's sort of like having the exponents themselves kind of cancel out. And same thing goes for logarithms. If you have one log equal to another log, and they both have the same base, then you're allowed to pull out the arguments, set them equal to one another, and it's sort of like the logs cancel out, and that way we set the arguments equal and solve the equation. So for example, number one, we would have to change the base of this one. We would change 16 to be 2 to the fourth. So we're not changing the value of anything, we're just substituting 2 to the fourth in place of 16 since they are equivalent. This now follows the property. I have bases of 2, so we're going to just pull off the exponents and set them equal and then solve our equation. Okay. And we can always go back and check by using the calculator and putting this value into my equation wherever x is located and calculate. We can always do that with any kind of equation. So now one-to-one property for logarithms. I have one log equal to another log. They both have the same base. And so I am able to basically cross out the logs and just focus on each argument, set them equal to one another, and then solve the equation. Okay, so we're going to move the x over to the left and then add the 7 on both sides. So we end up with x equals 5. And then I could also check with my calculator if I wanted to plug 5 back into my original equation just to confirm that it's correct. So we've been already solving equations using that one-to-one property. Now we're going to go a step further. Now that last class we learned about the other special properties for logarithms. Now we're going to use those properties in order to solve equations. So notice that number 7 here, we've got more than one log on the same side of the equal sign. So I've got 2 logs actually on the left side and just one of them over on the right side. So this is different. It doesn't fit underneath the one-to-one property because I don't have one log equal to another. So I can hopefully try to use these other properties and condense the logs on the left side, condense them so that then I'll have one log equal to another. I already noticed that they all have the same base, So that's a good thing. Now what I can do is let's focus on these logs here on the left side and see what can I do in order to condense them. There is subtraction in between these two logs. So I'm just looking at these two over here on the left side for right now. I have these two logs that are separated by subtraction, and that follows underneath my quotient property. So if I use the quotient property, I'm able to condense these two logs into one log by putting the first one as the numerator of a fraction, and then the second one as the denominator of my fraction. And that's because the property states that if two logs with the same base are subtracted from one another, that we can put them together as division under one log. So now that I've consolidated those two logs, I've condensed them into one. I'm going to copy down the rest of my equation. And now I'm ready to use my one-to-one property. So I can forget about these logs for right now. Just pull out the arguments and set them equal to one another, and then solve my equation. So here I have a multi-step equation. I've got x's on both sides, and I've got this big fraction here to deal with. So just as a reminder, when you are trying to move things around here, the first step that I would do would be to multiply both sides of your equation by this denominator. Multiply both sides of the equation by the denominator. So then that'll cancel out the denominator here on the left side. And this gets everything together like on one level playing field, sort of, kind of, to speak. So 18x, all right, now I've got to get my x's together. So subtract the 5 from both sides, subtract the 5x, from both sides. So this will be 13 equals 13x, because I did this. I subtracted the 5x from both sides. And now we're going to divide both sides by 13, and that's going to give me 1. 1 equals x. Okay. So now I'd like for you to try number 9 all by yourself. It's going to follow the same sort of process that we just worked through. As a matter of fact, it even has the same subtraction here in between these logs. So you are going to use the quotient property. Okay, so condense the two logs that are on the left side, and then use your one-to-one property in order to solve the equation. Now this is ln, so natural log, but you do not do anything different in any way. The properties are all the same for common logs and natural logs. And so we're just going to continue following through the same steps that we did on our last problem. Condense the left side into one log. So now I've got one equal to the other. And solve for x. right, so we end up with 6. 6 equals x. Okay, so now let's go on to our next page here, and let's take a look at solving by converting. Solving by converting means I'm going to be changing in between exponential and logarithmic functions. Okay, so let's say if I have an exponential expression like this, and I want to convert, that means I want to change that so that it's written as a log, change it into a logarithm. So we write log for log. The base of the log is the base of the exponent. The exponent, since it's 5 squared, the exponent goes on the other side of the equal sign. And then whatever it's equal to belongs over here next to the log. That's called the argument. So then if we want to check, it would be 5 raised to the 2 power equals 25. And that's what we had here. So that's what converting means. It means changing it from one form to the other. And it goes both ways. Now, if I have a logarithm, I can change it into an exponent. So let's say I have a log here. We read that log base 3 of 27 is equal to 3. Now, if I want to convert this, I will use my little arrows. 3 raised to the 3rd power equals 27. 3 raised to the 3rd power equals 27. Okay, so I'm going to be using the conversion process in order to be able to solve for x. So like number 16, my x, the variable in my equation, is in the exponent, and I need to get it down. Well, the only way to get it down is to convert it into the log. So here we have e to the x. Now for e, we use the ln for natural log. So to convert this, I would have ln, and the base is e. So we typically do not write the e down here at the bottom, but sometimes I'll go ahead and do it just to help make it a clearer process for myself. So the base is e, the exponent is x. So the exponent goes on the other side of the equal sign. And then the 2 is the argument. It goes in here. So this is actually as far as I can go without a calculator. So I'm going to go ahead and erase this little e here, since we typically do not write the base e there. It's just understood. I can actually go to my calculator now and calculate this to get a decimal approximation. So let's do that. Go to your calculator. We're going to type ln of 2, so natural log of 2. It's going to give me an answer. For us, we're always going to round to the thousandths place, so go out 3 decimal places, 0.693. 0.693 equals x. Oops. Oh dear. What a mess. Clean that up. Okay, so that's how we would convert. For this one, number 17, what I would do here, this is written backwards, and when you're trying to write it into a logarithm, you might find it easier if you just rewrite this the other way. So 7 raised to the 3x equals 4, so that the exponent is actually on the left side. You don't have to do this, but it kind of makes it a little bit more natural. That's what we're kind of used to seeing as we're writing the logarithms. So now with it written that way, I can write it as a logarithm with the base of 7. The exponent goes on the other side of the equal sign, and then 4 belongs here for the argument. Now I'm still trying to solve this equation for x. So there's another step I need to follow through with here. I need to divide both sides by 3 in order to get x alone and be able to solve for x. So right now this says that x is equal to log base 7 of 4 divided by 3. So I need to go over to my calculator. I'm going to type in log base 7 of 3. Log base 7 of 3. I'm going to hit enter. And then I'm going to, oh, I did it wrong. It's log base 7 of 4 divided by 3. All right, clear that out. Okay, let's enter there and then divide by 3. Just roll with it in the calculator there, 0.237. 0.237. Okay, so let's get into some logarithm equations that are a little more involved. Let's go to some that look like these, where you're going to need to first isolate the term with x. So here's some basic steps to help us with the process. You're going to want to move anything that has to do with adding or subtracting first, then move any multiplying or dividing. The next step here would be to convert. So convert here, and then there may or may not be some more things to take care of. So let's just take a look and see what we have on number 11. Okay. On number 11, I have the x in the exponent here. My ultimate goal is to get x by itself, but there's a lot of things that need to move before I can do that. Before I can get in here into the exponent, I need to move these other things. I need to move this 4. I need to move this 5. And when I say move, I mean move it to the other side of the equation. So let's start to do that first. Let's move anything we see that has to do with adding or subtracting first. That's what my step 1 tells me to do. So I'm going to add 5 on both sides of the equation in order to move this over to the left. So now I'm going to have 4 times 3 raised to the x plus 2 equals 8. Okay, my goal is still to get x by itself, so before I can get in there to that, I need to move the 4. The 4 is being multiplied by the exponent, so right now I will divide both sides by 4 in order to move it over to the other side. So now I have my exponent equals 2. All right. I'm down here now at step 3. I need to convert. I need to change this into a logarithm so that I can get x down out of the exponent. So I'm going to write this as a logarithm base 3, that whole exponent, okay? The exponent is going to go on the other side of the equal sign. So x plus 2 goes over here. And then the 2 is my argument. Okay, so I'm getting closer to my goal, which is to get x by itself and everything else on the other side. But now I have the plus 2 that's bothering me, so that brings me to step 4. Continue to move any terms that you still have to the other side so that x will be all alone. So let's subtract this 2 to the other side. And when I do that, I need to put parentheses around this log because it's separate. It's its own special thing. And then outside of that is where I will put the -2 that I'm bringing over. So what this should look like now is log base 3 of 2 protected in its parentheses, and then subtract that 2 that I just moved from the other side. Subtract that 2, and that finally gets me to where I can go and calculate to get a decimal for x. Okay, so we're going to go to the calculator and type this in. And we are going to do the log first, log base 3 of 2. So log base 3 of 2. So from here you can just enter and get that quantity and then just roll it into the calculator and subtract 2 for the next step. So negative 0.369, or excuse me, negative 1.369. And I have now solved my equation. Okay, so I will go back and show you that if you wanted to put parentheses around the log so that it looks exactly like it does on our paper, I can type it in like this, and then -2 all in the same line, but you just have to make sure that you've got your logarithm protected inside the parentheses. So just exactly like you wrote it on the paper is how it belongs on the calculator. Okay, so I want you to try and do number 13 all by yourself. Make sure to follow the steps. Follow these steps slowly but surely. Write down as much as possible. Don't try to do 2 or 3 things at once. And let's solve number 13. Okay, so you should have ended up with 0.764. And I'll even go back and show you if you wanted to put the whole thing, you could do the whole thing in at one time, do a fraction, and then type in your log. And you can get your answer all at once, 0.764. Okay, so you definitely need to practice. Lots and lots of practice is what's needed here. So my suggestion is to go on over to the next page, page 21, and practice. All of these are good problems on this page, but I would say maybe start out and just do the evens for your homework, and the answer key will be posted or is already posted on Canvas.